The principle of triangle of forces states that if three forces are in equilibrium, they can be represented in both magnitude and direction by the three sides of a triangle taken in order. So, an illustration for this is the triangle above, so which gives a triangle which is used to represent the equilibrium of three forces. So here the two forces P and Q are both in equilibrium with force E. So that is, the effect of the two forces is neutralized by the force E. So now let's take an example for this. So a mass of 2 kg is supported by two cords which make angles of 30 degree and 50 degree with the vertical. Calculate the tension in the two cords. So to solve this, first of all, the mass, which is given in kg, will be converted to weight, because weight is a force. So that will be W is equal to mg, so which gives us W is equal to 2 times 10, which is 20 Newton. So then we are going to interpret the diagram. Since it says that the mass is supported, that means the mass is hanging and is in position, is not moving, by two cords. So one of them is inclined at angle 30 degree and the other inclined at angle 50 degree to the horizontal. So the diagram will be like this. So which is showing that the force Q, which is tension in the cord, is inclined at 50 degree to the vertical, and that of P is inclined at 30 degree to the vertical. Then the weight is hanging downwards like this. So this diagram can be redrawn, so according to the principle of triangle of forces. So we can rearrange the forces such that force P and Q are connected to each other from tail to end. That is, the end of one connects to the tail of the other. The end of one connects to the tail of the other. So we can choose the end of P connecting, the head of P connecting to the tail of Q. So we have something like this for P. So something like P. So then if this is P and then Q goes this way, so if this is Q, then 20 Newton force go vertically downward. So this is the 20 Newton force. So we have represented it in form of a triangle, and we know that P and Q are inclined to the vertical at 50 and 30. So P is inclined at 30. So P is inclined to the vertical. This will now be our new vertical at 30 degree. So the angle here will be 30 degree. While Q is inclined to the vertical with the angle of 50 degree. So this is the 50 degree. So from there we can use we can get the third angle, that is this. That will give us 100 degrees, since sum of angles in a triangle is 180. So the third angle here will be 100 degree. So let us redraw the diagram and then do the calculation. So we have the 20 Newton force, we have the Q and the P. So the P, which is the P, which is at 30 degree, and Q, which is at 50 degree. So the P, which is at 30 degree, and the Q, which is at 50 degree, and then we have 100 degree. So if we want to calculate P, we can use sine rule. Sine rule says that A over sine A is equal to B over sine B is equal to C over sine C. So from there we can say that P over sine angle facing P is 50 over sine 50 is equal to 20 Newton. The angle facing 20 Newton is 100 over sine 100. So from there we cross multiply. So we have P is equal to, make P the subject, it's equal to 20 sine 50 all over sine 100. So calculating this, the tension in P will be 15.56 Newton. 15.56 Newton. So that's for P. Then we will do the same thing to calculate Q. So Q will be Q over sine 30 is equal to 20 over sine 100. Since the angle facing Q is 30 degree, so Q over sine 30. So we have Q over sine 30 is equal to 20 over sine 100. So making Q the subject, cross multiply. So we have Q is equal to 20 sine 30 all over sine 100. So, and that gives us 10.15 Newton. 10.15 Newton. So that's the value of Q.